In the first example, it states, telephone numbers in the U.S. consist of a 3-digit area code, then a 3-digit prefix, followed by 4 digits. The area code and the prefix cannot begin with 0 or 1. With this design, how many different telephone numbers are possible? So we're certainly familiar with telephone numbers, our phone numbers. We have an area code, then this 3-digit prefix, and then there's that dash, and then we have these 4-digit identifiers. So I'm just going to write down an area code like this, made up of 3 digits. Often it's enclosed in a parentheses here. Then we have that prefix. That's 3 digits. And of course we know we have that dash. And then we have this individual identified 4-digit numbers that identifies who you are. Now it states that the area code and the prefix cannot begin with a 0 or 1. So if this is our area code here, this first number here of the area code cannot be a 0 or a 1. It could be a 2, 3, 4, 5, 6, 7, 8, or 9. So how many digits are there for this first number of our area code? Well, there's 8. The next number has no restrictions. It can be anything. So there are 10 digits for the next number. And the same for the next number of the area code. The prefix, that's just like the area code. The first number cannot be a 0 or a 1. So there's 8 numbers to start off the prefix, but then this can be any digit, so that's 10 digits to choose from. Here's 10. And of course, our 4 digits that identify who we are, that can be made up of any numbers. So there's 10 to choose from for the first number, 10 for the second, 10 for the third, and of course, 10 for the fourth. And of course, if we use the fundamental counting principle, if there's so many ways that the first number of the area code can be, and there's so many ways for the second number, how many ways can there be altogether? We simply multiply. And of course, we do that for each digit here. There's so many ways for this to occur, so many ways for this to occur, so many ways for this to occur, and so on. We just multiply them. And a quick shorthand way of being able to write this is we have 8 here, we have 8 here. So I could write this as 8 squared times 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th. So 8 squared times 10 to the 8th. That gives us 6,400,000,000 different phone numbers in the United States. So we'll use the same approach for this next example here, rolling the doubles. In the game of Monopoly, on any roll of doubles, a player is allowed to take another turn. Suppose you got 3 turns in a row while playing. How many different ways could you have rolled doubles? Now, as in any word problem, we're going to come across a lot of word problems as we continue on in this chapter, is to make sure that we're clear on what's going on. You have to roll doubles, so we have to determine how many ways to do that. And when it says 3 turns in a row, that means your first roll has to be a doubles, your second roll has to be a doubles, and your third roll can be anything else. So we're going to be rolling doubles twice. And if you remember from our dice table, there's 6 different ways you can get doubles. You can roll double 1s, double 2s, double 3s, 4s, 5s, and of course 6s. So if there's 6 different ways of rolling the first pair of doubles, and there's 6 different ways of rolling the second pair of doubles, how many ways can we get doubles altogether in order to get 3 turns in a row? Well, we simply multiply. And of course 6 times 6, there's 36 different ways to roll doubles in order to get 3 turns in a row. And there you have it.